Friday, I'm going to be hosting a debate at TWIML Con. It is the TWIML Con off. So it's the ending of the TWIML Con conference. And there's going to be some people from the community that are going to be joining in the debate. We're going to be talking about if a data scientist should know Kubernetes, and if it's going to be one machine learning tool to rule them all, or if it's going to be best in class tools. And so we will have...
I have really strong opinions on that, as you might imagine.
Wait, which one? The best in class or the one tool to rule them all?
Oh, that whether a data scientist should know Kubernetes.
Yeah. Should they?
No.
No.
Because
really?
if I mean, and I'm speaking as a tool maker. If a data scientist needs to know Kubernetes, whoever has designed the tool or the framework has completely failed. Right? Kubernetes is a way to build frameworks. And as somebody who's basically, writing the software for Kubeflow pipelines, or someone who's writing, a training framework, or something like that, then you need to know Kubernetes. But as a data scientist, you should be able to know. I think containers is the last level of abstraction that a data scientist should need to know about. Anything lower level than that is just ridiculous, right? You need to be able to say, here's my container, distribute it for me, scale it for me, give me resilience.
Yeah, I could see it. Oh man, well, you're making it, you're going to give the people who are arguing for this or against this a run for their money. It's going to be difficult now. I love it. That's great. So I completely agree on some of this. Like the end user, your end user is going to be the data scientist. So if a data scientist does need to know Kubernetes, it's just so much that you're asking them to know, right?
And I mean, this is like asking a web developer to know how web servers work. They shouldn't.
It should. It's not. Yeah, it's not realistic.
Reason why we have the HTML and HTTP protocols.
Yeah.
Know how HTTP post works and how HTTP get works, and trust that on the other side that they can take care of concurrent HTTP posts, and they can take care of encryption, and they can take care of key management. You and I shouldn't worry about that. We should just be able to go write our web pages and go home and get a good night's sleep.
Yeah, exactly. I mean, and somebody's putting here in the chat too, it's like the idea of a full stack data scientist that sounds fun, and it's a great theory, but the majority of people, I think it's very, very out of their range. It's very difficult to be specialized in data science and staying up to date with everything, all these papers that are coming out every day in data science. Like if you're looking to do anything with deep neural networks or any of that you need to keep on top of. And then you're asking that person, oh yeah, and by the way, just go figure out Kubernetes, which there's a whole nother job description for.
Exactly. It's like expecting someone who writes code in Java to also know assembly, and to also know how to solder circuits together. Yeah, sure. It would be awesome if they could basically go write the optimized assembly code so that they can drop down from their Java to assembler level for something. But it's not the right level of abstraction. And as people who create libraries and people who create frameworks, expecting your users to have that level of knowledge and means that the abstraction isn't good enough.
You're not doing something right. So that's amazing. Well, that's one way to start Meetup. I love it, Lak. We've already gotten off to this.
Just jump in and say, even before you ask me a question, I have a thought on that.
Yeah, exactly. So those are the announcements and compliments of Lak. the debate. Maybe I got to get you to come to the debate too. We'll see. Are you busy this Friday?
Yeah. Let's talk about it. Yeah, I'm not sure about the time, but yeah, if I can, I would love to.
Oh, that would be amazing. So let's talk about this book, man. But before we even do that, this I see a hilarious thing in the chat, and it's Mehdi's saying, "Hey, can I give you some emails so you can explain all of what you said to these people I know?"
It is recorded, isn't it,
Exactly.
Demetrios?
Mehdi, we
Yeah.
will let you know when this is on YouTube so that you can just send all of these people the emails and the timestamp and say, check this out. So, Lak, man, I think it would be good if you can start by just telling us how you got into tech, how you even, like, what drove you down this path.
Yeah. So what drove me down this path is kind of interesting, right? So I did research on weather prediction. So basically building systems that predict severe weather. So tornadoes, hail, lightning, flash floods, etc. So this was at the National Severe Storms Laboratory. And as you know, right, these days, if you're a scientist, you're a programmer, right? Where 100 years ago, if you're a scientist, you learned how to use a microscope, right? And you learned how to do experiments. The way you do experiments today as a scientist is that you write programs, right? You write simulation software.
Totally.
So the way I got into tech was that tech is a tool. And I think that's a perspective that is sometimes missing in the tech industry, where we've sometimes built technology for technology's sake. But I approach technology as a tool to get me to do the thing I really want to do, which in that case was understanding severe weather, understanding how to predict severe weather, understanding or building systems and tools for making decisions based on severe weather. So, for example, if you're flying an airplane, you need to know what height to fly the airplane at. If you have an airport, if there's a lightning strike nearby, you need to know whether to stop flights landing at that airport. Or if you're an emergency manager and there's a tornado headed towards your town, you need to know, should you sound the siren, have people get into their tornado shelters? Okay, or if you're that was basically the end goal, the end result, and you will see this kind of that view, I think, in the book, where every once in a while there will be like a weather scenario.
I was gonna ask. That was exactly what I was gonna ask. I was like, wait a minute. So I think you just gave a tell on which ones you wrote, because there's like, the airport scenario, or if you're dealing with this, airlines need to know how they're doing it. So I guess those are yours.
Not necessarily, because I think, again, you had Sarah on a few weeks ago, and we discussed a lot of these things as we wrote the book. And in some cases, right, I would say, hey, no, Sarah, here's a great example, here's a great data set. So again, not giving things away, but there are some graphs in the book, and there are some anecdotes in the book where I may have basically pointed my colleagues, Mike and Sarah, at them, but they're the ones who wrote it.
Oh, that's incredible, man. So the first thing that I guess I want to ask before we even jump into the book is, there is this paper that my friend David and I have been absolutely loving. We did like a 4-part series on it. It's the ML maturity level from Google. And I realized later on when I was reading the book, I'm trying to find it right now, but the same maturity level is in the book. And I'm wondering, did you write that paper?
I was one of the authors of that paper.
Man.
So that was a group effort, and there was about 7 or 8 of us. I did a very minimal, right? So there's a whole bunch of my colleagues that did it. So basically, if you look on cloud.google.com/solutions, that is a set of solutions that comes out of our team. So those are not signed.
Yeah.
because those are by all of so it's by Google Cloud. But yes, this cloud AI adoption model and the maturity curve model and all of that is based on a lot of the work that we have done with customers in terms of understanding where they are and what like how they move up the maturity model and what kinds of things they need to invest in. Because it's also the case, I think this ties back to our first conversation where we talked about what kind of infrastructure do you need, and not everyone has the need for the most complex infrastructure involving feature stores and their own Kubernetes clusters. In a lot of cases, a managed service for prediction and your standard Python development environment is enough, right? And we don't actually need a full-fledged experimentation framework, because it may at the early stage of maturity for a lot of companies, you're not actually developing very bespoke ML models. You're often taking a model out of TensorFlow Hub, or you are doing transfer learning. And at that point, the amount of infrastructure that you need and the amount of recording that you need might be somewhat minimal. And again, we suggest that you don't stop there, you move up to the next level of maturity. But what we always suggest is get going rather than spend a lot of time building infrastructure that you may or may not need.
Yes. And that's such a great point, because that's something that we talked about a lot when we were going over this paper. And it was very much like, hey, yeah, these are the levels, the maturity levels, but don't feel like you need to be at level 2 right away, especially. And maybe sometimes level 0 is good enough for your use case. And that's a huge thing. And so that's actually one of the questions that I wanted to get into, because in the, I think it is in the feature store chapter of the book, or the design pattern, you talk about how it's a bit more of a bloated solution, right? And there's a trade-off that happens there. So I'm wondering, how do you know, or when do you get to this point where you say, okay, we're going to add this complexity for the ease of use? How do you know when that point is, right? To bring on complexity for the sake of making things a little bit easier.
Absolutely. So again, when you think about the feature store, it's about being able to foster reuse within your organization. Reuse of what? Reuse of calculations on your input data, right? What that means is that you need to have this kind of model of your data that is used in multiple models. So feature store, for example, the customer that we worked with feature store on was Gojek. And they were building, and Gojek is this Indonesian firm that delivers food, and they do a whole bunch of other things. Okay, but a key part of many of their machine learning models was a concept of a driver, right? Of someone who's driving. And so the idea was that once you have all of the information about a driver pulled in, it would be great if every one of the other models could simply say, here's my driver ID, give me an embedding of a driver, which captures all the information that I know about this driver, their history, their preferences, like how long they take to deliver, all of those kinds of things. And you want to pull it all in one sense. And then you basically have somebody upstream, right? That's basically creating this driver feature. So the way that you think about it is very similar to the way you think about it in software. Should I make this a library, or should I just write it as a code right in my function? And it comes down to how often are you going to be reusing it, right? So as we know, when we do software, we basically have things that are simply, you write the code yourself, things where you basically have a library and you call it, and then you have the third level where you basically wrap it up in a microservice and you basically call it via an API. A feature store is a microservice level. It's not for everything that you need that microservice level. For many things, having it as a library is good enough. And the idea of having it as a library is that you basically have a pipeline that creates these things, and you're just pulling them as part of your part of the experiment framework for multiple ML models. You don't need this idea of this always up-to-date driver information. That's the level at which you need the feature store.
Yeah, that's great. And now it totally makes sense because you were talking with Gojek, and shout out to Willem and the Feast team. I noticed that you put a little blurb about Feast and how that works in the book. So that's very cool. And now I totally understand where that came from and how that all connects. So the next thing I'm wondering then is, for you, like, I'm sure you've heard this being thrown around, and it is the idea of best practices being encoded into tooling, where like if you use a tool, it ensures that you're going to be following the best practices, right? You've probably heard that argument. And so I'm wondering, what are some of the best practices that you've seen being used in tooling? And is it something that we could say like, okay, it's some of these design patterns that you speak about are just being wrapped up into a tool, and so that it ensures you're using some design patterns, and that those are the best practices at the moment?
Yeah, and if you that is absolutely true. And some of these are tools, some of these are libraries, and some of these are services. Coming back to that old discussion we had in the feature store, there's multiple ways to reuse them, and you find them being used in. So, for example, when you talk about an embedding, TensorFlow has a method called make me an embedding column, right? So that you can basically take your standard structured one-hot encoded field and run it through an embedding. You don't actually have to create a dense layer and remember how to do that. You just use the function, give me an embedding column, and it's part of your training network. And so that is one way in which tools start to support this really common concept that when I'm training sparse models, which is very common in structured data, I will often want to not use the sparse column directly, but I want to wrap it up in an embedding column. And the TensorFlow framework makes that easy, right? So that's one way in which we see that best practice basically gets incorporated into the tooling. You have to know why you're doing it and why it is that you're wrapping it up, and remember that this is about dimensionality reduction. And so remember to not just do it for absolutely every one-hot encoded column you have, because if you do that, then you're basically losing a bunch of the actual information encoded in the one-hot encoded column. So you've got to think about, is the closeness relationship important to me? And that's where the design pattern comes in, for you to understand the purpose of the embedding and whether that purpose, that closeness relationship, makes sense in the context of this one-hot encoded column that you have. So that's one way in which we do the reuse. On the other end, you say, okay, we want to have serverless predictions that are stateless. And yeah, we can go do that ourselves, but it's much easier if you have a managed service to which you can go say, here's my model artifacts. Please go ahead and run them very efficiently for me, auto scale it for me, and then you basically have your prediction infrastructure that is a way to get this extremely effective way to get your stateless serving design pattern in there. So you have tooling that supports it at the microservice level as well, right? And then you have best practices that are in between. So you may have things that are available where you can basically turn them on or off, like distributed strategy. It's going to be different ways, and you kind of decide, okay, my model is very big and I have to split it across multiple nodes, or my model is small enough that I can mirror it. And depending on that, you choose your distribution strategy. So that's somewhere in the middle where you basically you have a choice of how you want to do the distribution, but all the hard work is handled for you by the tool.
Well, and I guess that is a perfect segue into this idea that I've been grappling with, and that there's so many different use cases for machine learning, right? And to try and tackle all of them and put them into different patterns, how did you even how did you even start to try that? And how was it that you were like, okay, this is something that we keep seeing, so we should write about it? Is it just that you continued having the same conversations and you're going around in circles? I know you're also a prolific blog writer, so maybe it's like it's a bunch of little blog posts that you had and that you had been seeing, and then you said, well, hey, let's put this into a book. How did that happen? And like, how did you even think, I want to say, like, the audacity to think like, hey, let's go and write some patterns that we can
Right.
use in this gigantic field that has so many different use cases?
Right. So I think those are three separate questions. So let me take them one at a time. Okay. So the first one, like, how did we kind of decide that these are the patterns that we need to include in the book? Okay. The way that we essentially did that is that I think all three of us are very fortunate. Sarah, Michael, and myself, we're all very fortunate in that we work with lots of customers. Right. So Michael teaches at what we call our ML immersion program. And that involves companies sending 5 of their engineers to Google, and they spend 18 weeks with us, right? So several months, so we work alongside them on a really challenging problem that company has to solve, and then we kind of do touch-ins with them over a period of a few months. And so Michael has worked with a number of these of Google Cloud customers in helping them build their models, and very familiar with the challenges when they first come into our program, and like that, as we discover the problems, as we go build the solutions, as we discover the problems with their data sets, and everybody has problems with their data sets, right? And then we say, okay, now how do you resolve it, and helping them through that process. And we see the similar problems occurring, whether the company is basically in retail or in finance, or if they're in conservation, right? So they all have things that are kind of somewhat similar, and we're able to kind of like that's one way in which we discover it. We also discover it because we talk to developers. And we basically see that, okay, here's the kinds of things that developers do a lot. We work with a number of internal Google teams who are saying, like, here's how we organize our projects, and here's how we've done this particular ML model that goes into Google Meet, or this ML models that go into Google Photos, and this is how we productionized it. And we say, oh my God, that is a really neat idea, right? And we say, okay, who else uses it, and why isn't it getting used in other places? And that's part of what Google Cloud does. Is in many cases we look at neat things that are being done, because again, we've been operationalizing ML models for a long time, and looking at how to externalize some of that as Google Cloud services. So, and that's something that I'm familiar with, because we basically been working with a number of Google teams. So these patterns come from both cool new technologies that have been done at the bleeding edge, right? Common customer problems, because customers are facing them, common developer problems that developers are seeing, and that's where the three of us meshed in really well, because we see things from 3 different perspectives, and we're able to put them together and say, here are the things that here's a box, and we kind of shook them a little bit and said, okay, these are the ones that are kind of common, and let's go talk about them. So that's the first bit. The second thing is, why did I get the audacity to think that this is something that is worth doing? And and you put your finger on it, it was just that I write a bunch of blog posts. And I had basically was giving a talk at a Google developer event, and that was when the Keras feature column capability was being developed. So I was working with the Keras team on the usability of that interface, and I was trying it out on different models and so on. So that was obviously, that was top of mind for me. So when the GDE event said, hey, can you come talk? I basically went and talked about the feature column. But just before I talked about the API, I thought it'll be good to talk about why this API is important. So I talked about the need to save transformations between training and prediction. And then I said, this idea of explaining why you need to have this API capability is an important thing, because otherwise these APIs look unnecessarily complex and people are like, why am I even using this stuff? Why can't I just roll it off myself? We need to explain, right, the reason for them. And that's, that explanation itself, people found extremely useful. I got a lot of conversations after the talk, and everybody was like, that explanation that you gave about the transform was very useful. What other things are there? And that was the thing that prompted me. What other things are there? I said, okay, let me go ahead. And so I wrote about 5 blog posts on these, like, why do we do checkpointing? Why do we do transforms, etc. And then I basically did talks on these. And based on that is how realized that there was a need to explain these concepts and these, these patterns. And that was basically the genesis of the book. And then I basically, looped in Mike and Sarah, and we basically, built up the book.
The rest is history. That's amazing. Yeah, I mean, I could see that. It makes total sense of the why. And also, again, what you said there, you just dropped in a little breadcrumb to the last question of when you tell someone why the API is like it is, and then they don't have that idea of, oh, I could just go do this myself, but maybe they go and do it themselves and they don't have the fundamentals there. So it ends up being much more of a headache.
It ends up not solving the problem that the API is solving.
Yeah, completely.
But not all things are that way. Like I said, some of these patterns are driven by, here's how it's being done in the API, or this is how leading edge ML teams are solving this problem that they're encountered, which you may not realize you're going to encounter until you actually encounter it. So it's nice to build off of the experience of other teams that have already been there.
It's actually kind of funny that you say that, because we just did a podcast with Charlie Yu, who is a machine learning engineer at Workday, and he said that reading this book, it was one of those moments where he read it and he was like, oh, that's interesting. But then he went back to work like a week later and he encountered the problem and he said, this is from that book.
It's like one of these things, right? So if the first time someone points out a bird to you and you've never even noticed a bird before, but someone says, hey, that is a warbler. And then for the next week, you just see warblers everywhere because suddenly you've been, someone has shown it to you, and you kind of now you recognize that it's there and you've been missing them. And part of this is that, so now that you've recognized it, it's not only that there's so many trade-offs and aspects to it, and it's very likely that you've thought about some of them, but you've not thought about others. And that's part of what is I think useful about a design patterns book. I read the Gang of Four book when it came out, and I'm dating myself, right? So it came out in 95, 96, something like that. And I can look at the code that I wrote before and after I read the Gang of Four book, and there's a huge difference in terms of how reusable it is and how repeatable and maintainable it is. Of course, as with everybody who read the Gang of Four book, I went overboard. I put in the visitor pattern everywhere, and then a few years later, I realized, oh my God, I shouldn't have gone that far. And that's kind of the why, right? On the feature store, we made it very clear: please don't use it unless you have to. To me, the feature store in the ML design patterns book is exactly like the visitor pattern in the Gang of Four book. It is a thing that is completely will save your bacon when you're building a really huge ML system, but most smaller ML systems don't need it.
That's such a good point. And, I think either you're going to write it or maybe I'll write something that is the 12 steps of being a machine learning engineer anonymous or something, where the first step is actually recognition of when you're doing it, and then the next step is acceptance, and you go through these steps because, like you said, you just have to realize that it's there first, and then you can start seeing, oh, okay, yeah, maybe I can change this, and then not going overboard is key and crucial. So there's some great questions coming through in the chat, and I want to be respectful for everyone that is here and throwing these amazing questions in the chat. The first one that I wanted to mention, which is, it goes along with a question of mine, so it's a little bit mine and the chat.
Sun in Seattle all of a sudden.
Oh yeah. It's not raining there? That's surprising. So
all right. Yeah,
there
it's exciting to have sun, but
yeah. So the question goes along with something that we tried to do in some of the first meetups, and it was along the lines of like the MLOps hierarchy of needs. And we had a great guest on here, Phil Winder, who's done a lot of stuff with Kubeflow. Maybe you actually know him, but he was talking about what his hierarchy of needs in MLOps is. And then this question just came through the chat of like, what would be in your mind some of the hierarchy of needs or hierarchy of design patterns, and how you feel, because I imagine that all of them are in here for a reason. But like you said, a feature store has a very specific use case, and serving models has a totally different one, right? So there's, in my mind, I see there's a bit of a hierarchy, but I'd love to hear from you.
Okay. I don't see them as a hierarchy. I see them as more of a handoff, right? So when you're in this process of developing ML models, your core need is the ability to represent your data effectively, right? The most valuable thing in machine learning is data, and you want to make sure that you're using it effectively. And using data effectively means that you have to trade off two things. You have to trade off the less data you use, the more you can be sure about its quality, right? And the more data you bring in, the more likely it is that you have to basically treat quality in a more statistical way, right? You're not absolutely sure about every single bit of data that you're using to train your system. You have to basically look at quality in a more statistical way, which essentially means that as the size of your data increases, the way in which you go from treating data as a pet to treating data as a cattle, coming back to the old Kubernetes analogy there, right? And as you start treating data as a cattle, which is what we do in machine learning, you've got to basically build up the tooling to be able to deal with data as a cattle while not losing that quality focus. So from a developer standpoint, the first and most important thing is that hierarchy of needs that's going to grow as the size of your data increases. The way that you prepare your data, the way you clean your data, the way you analyze your data for data drift, all of that is going to become more and more sophisticated as you go up, right? The second thing is, once you have your data, you also will have to incorporate it into your model. And when you incorporate it into your model, it's the exact same thing, right? You might basically treat your data and you might do feature engineering to basically improve all of the ways in which you represent the data and the quality. But as the variety of data increases, you want to basically look at how can I automatically start identifying features. And that's where things like feature crosses and embeddings come in, which is like, there are two sides of this problem. A feature cross is basically automatically doing feature engineering understanding that combinations of features are important, and embeddings are ways of automatically doing dimensionality reduction, understanding that your data, that huge variety looks very appealing initially, but it is actually not representative of the information content of your data. Right? So that's the second level at which, as a developer, the way you think about it. Okay. And then the third thing is, once you start developing your ML models, now you basically start thinking about how do I compare two models? How do I compare experimentation? How do I deal with imbalance? Right. So many of the patterns in this book are about improving the quality of your models, sometimes by forcing you to think about them differently. Is something a regression problem just because you're predicting a number? No. In many cases, if you bucketize the number and you change it to a classification problem, you will get amazingly better performance because you can have probability bins on each of your buckets. So those are all the kinds of ways in which you improve your ability to deal with different kinds of problems as the developer of ML models. And then you basically take that hat off, you put a new hat on. Okay, I've developed my ML model. Now I want to deploy the ML model. What are some of the problems that I'm going to face when I'm deploying ML models? Sometimes the problem that you face is that you want to basically handle millions of users simultaneously. Sometimes the problem that you face is that you have millions of instances that you need to predict as quickly as possible. So the scaling is different and how you deal with them is different. So those are the deployment issues. And then we basically move on to the next step, which is, okay, now you've deployed your model. Now, how do you basically satisfy your stakeholders? Explainability. How do you satisfy things about reuse and maintainability? And that's where the ML engineering bit comes in, where you don't think about every ML model as its own thing by itself, but as this group of things that you're asking users to take advantage of when they make decisions, and how do you support the decision making of users? So it's really not, you don't want to think about it as one group of things, but it's things that you use at different stages of an ML lifecycle.
Yeah, and not one is better than the other. It's more what is happening and what are your needs right now. And I like this analogy, like, okay, what hat are you wearing? Right. And then if you've gotten to this stage, then you probably can be looking at these things as opposed to, oh, this is the most important one. And then you go down and find the ones that are less important, but you still should be aware of. So, yeah, great answer, man. I really like that one. Now, the next question we've got in the chat is from Ron, and this is a really good one too. It's a little bit wordy, but the gist of it is, are there patterns out there that are yet to be discovered? And so the backstory of this is, how do you balance the exploitable versus explorable ML patterns? And the known design patterns in your book are now certainly exploitable, yet so much of what we do is exploring new space. So are there patterns out there still yet to be discovered?
Okay. First of all, there are patterns out there that we did not include in the book, right? Because we did not see enough reuse of them. Okay, so but as technology improves, as more people do ML, I'm pretty sure that there's going to be more and more of these things that become more reusable. So as an example of one that we did not include, right? Because I'm sure everybody's like, what about which one did you include? There is this, if you look, you can do a Google search for this. There is a project called Mediapipe. And Mediapipe is a way to do ML pipelines for when you're building mobile applications, and very specifically about doing mobile applications for things like object detection, etc. And it turns out that when you build those applications, it's not one ML model, but dozens of ML models that you need to link up together. So and it's for a very, 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 very specific task. And there's a lot of very interesting ideas in when you will want to build a solution like media pipe versus using a more general purpose solution like Kubeflow pipelines. And when you will want to basically, or a more, or a lower level solution like Cascade, right? So Cascade and ML pipelines are the two closest ones to what we cover here, but media pipe is fundamentally different. But media pipe is the only one that we saw. And one of our things was we want this to be repeatable. And we did not see a second similar use case of something like a media pipe. So we couldn't come up with a general purpose name of it. We couldn't just say, hey, look, media pipe does something cool and interesting, right? So to me, a pattern is something that is applicable in multiple contexts, in multiple industries, whether it's NLP or it's images or it's something else, right? So it's that idea of that it's the same idea that you can implement in multiple ways, and it's a best practice. That I think gets at what is being asked, right? Whether it is exploitable or is it something that you're exploring. If it gets to the point where it's exploitable, it's something that is repeated and you do it over and over again, and you can do it in multiple contexts, then it becomes a pattern. And this is, of course, like, everyone is smart and we all keep discovering new things, and there's going to be new ones that come out. And some of these things that we're developing might become obsolete, and we may say we don't want to do those things anymore. And if that's the case, we should be like, we should go back and revisit some of these things. Absolutely.
Very nice. Okay, I see that. I can see that very clearly. It's like, if it's such a specific use case, even if it is really, really cool, you can't call it a pattern yet. So
correct.
That's awesome. Now let's take another question from the chat. There is a question wondering about the differences in your mind of ModelOps versus the term MLOps.
ModelOps versus MLOps. ModelOps seems to think that the most important thing about machine learning is the model. I think with MLOps, you're leaving open the possibility that you need to basically improve the speed at which you deliver data, which can often be the fundamental blocking thing, right? Between having something that works really well and something that doesn't work as well. So I like this idea of MLOps because it forces someone to think a bit more holistically than thinking of it as ModelOps, which would be all about, let me improve the ML model and not worry too much about about the ecosystem that it lives in. That would be my take.
Awesome. So next one up is, do you feel that a DevOps engineer is better suited to make the transition into becoming a machine learning engineer?
Who's best suited to becoming an ML engineer, right? I've seen really good SREs become extremely good ML engineers. I've seen very good data engineers become ML engineers. What I haven't seen are data scientists becoming ML engineers. At least the ones that I know that have done this have quickly gone back to being data scientists. They did not like being an ML engineer. Right?
Oh man!
So I think anybody who's basically used to building backend systems, you might basically say, I'll pick up the ops capabilities of this. Or someone who does ops says, I'll pick up the statistical possibilities of this. But someone who's like a data scientist typically is interested in solving new problems. And they find it very, very difficult to focus on the detail and the quality that's needed to be successful in the ML engineer role.
It just makes me laugh, because the idea of the data scientist that tries to then become the machine learning engineer, they're the ones who have the hardest time. And I could see that, because you're not very familiar with so much that is wrapped up in this machine learning engineer title. But then again, also, I think what is very difficult right now in the age that we are living in is that a machine learning engineer to one company has a totally different role than a machine learning engineer at another company. And your expectations at one company as a machine learning engineer is a completely different set of standards than at another company, whether that's an enterprise or a startup. There's many different factors at play there. So I'm thinking there's another great question in here that I wanted to talk with you about, and it was on the idea of okay, so Todd Underwood, who I mentioned before, was on here, and he's a fellow colleague of yours at Google, and he was talking about, he actually did a talk on machine learning problems that they encountered and how so many of them were just problems with distributed systems and it wasn't machine learning specific problems. And so
Correct.
I think there's this question that is asking like, would like to know what Lak sees as the fundamental difference between a machine learning design pattern as opposed to a software development design pattern. And it's actually funny, just to a little bit more of a tangent before I let you talk, is that we had Manoj on here from Salesforce last week. And a lot of what he was saying was echoing this, is that a lot of these problems are software engineering problems and they aren't so specific to machine learning. But I think that I'd love to hear your take.
Right. So these are definitely software engineering problems, but you don't have to solve them using just the standard software engineering solutions. With ML, you basically know the specific domain in which they happen, and therefore you basically can have a somewhat more of a custom solution that takes into account the special context in which this software engineering problem occurs. So if the problem is of maintainability, that's a software engineering problem. But ML poses another constraint in that the maintainability has to cover both the maintainability of the data, which can change, and the code, which can change. And you need to basically make sure that your data and your code are in sync. And that poses a higher level of maintainability concerns. And that's why you talk about data versioning and model versioning and how to basically keep those. And that's so that's essentially what we're talking about here, is that the problems may not be new, but sometimes the problems are wider in scope, and the solutions themselves, we don't have to reinvent the wheel. We can go look at what has been done in the software engineering world and use those same tools. We're not talking about basically building, versioning is something that's very well known in software engineering, but isn't quite well practiced when it comes to data science. But it's something that we have to bring that discipline of version control into data science. And that's basically what we're talking about here. What are the things that we need to version control? We need to version control the data. We need to version control the artifacts that come out of the data, and we need to make sure that all three of them are interlinked so that the metadata captures all of those.
Exactly. And even the idea of the CI/CD, it's that same kind of thing. And the paper you wrote, or the paper that you all wrote about the continuous training, is very much to that idea. Like, hey, let's take these best practices from software which have been proven, and then let's add on top of them, so you're standing on the shoulder of giants and you don't have to reinvent the wheel. So there's another great question in here, and thank you all who are in here for asking questions, because you all are amazing. You're making my job easier. Not that it would have been difficult to talk with Lak. I see we're kind of coming down to the wire, but there are some incredible questions, so let's get to it. When you were working with the companies at Google, so this is, I think, referring to the story you told.
The ML immersion program.
Yeah.
Correct.
And did you give them a tool chain and a better infrastructure, or was there more to it? Did they have to rethink their corporate culture? I ask this because DevOps is often mistaken as just pure toolchain.
Right. So oftentimes, when a company sends their folks to us for the ML immersion program, it is part of a larger digital transformation that's being carried on at the company. So yeah, the person asking the question is absolutely right. Our small team didn't work with the company on doing the overall transformation, but overall there were transformation workshops happening. We actually did discovery workshops with their product managers to identify situations in which they could take advantage of data analytics and AI. Not everything needs to be machine learning, right? Lots of things, simple visibility into data can be enough. So we'd actually think about where do we add visibility into the data that's coming in, visibility into business processes, visibility into how decisions are made, how to basically transform them. For example, like one of the companies is basically a retailer, and the transformation for them was how to basically speed up inventory management, be able to support things like curbside delivery, and so on. So that was the overall umbrella program of digital transformation that involved a huge culture change at the company. And in that, they wanted to basically have their core data science teams also up-leveled. And in order to do that, they basically said, okay, take this group of folks, and we will basically put them through an immersion program at Google. So that's basically what it was. And again, yeah, you can look this up. It's called the Advanced Solution Lab. So just go ahead and Google Advanced Solution Lab and Google Cloud, and you'll find more details about this program.
It's basically just giving superpowers to your machine learning and data science team, I imagine. So Sam is asking a question in here about are we not being too protective of the data scientist as a role? Very rarely do we have a team that is big enough to allow dedicated roles. How do we encourage data scientists to look at the wider picture and get involved in the earlier roles like data engineering?
Right. So I know we don't have much time, but my core advice to a lot of companies is that you want to hire a software engineer who can pick up enough of the data science to basically be successful. And it's only that the larger you are that you can afford to have these research-oriented data science roles. And that's a good way, I think, to think about it, is that if you're hiring data scientists in your company, you're hiring them because you want them to be able to do exploratory, ambiguous, destination unknown kind of work. If it is very much around, here's a problem I want you to solve, you are better off hiring a software engineer who knows enough about machine learning and data science than hiring someone with academic training in some of the PhD in computer science, for example. Right? That's a misfit if you want them to do more than that research and exploratory work.
Yeah, and I've heard that echoed so many different times, and it ends up just making the company not appreciate the data scientists when you hire them, because
the company doesn't appreciate the data scientist. The data scientist is very unhappy in their role because they're doing very operational kinds of things. It's a mismatch between the aspirations of somebody who wants to be a data scientist and the needs of a small company that needs to productionize their ML models, that needs to build a lot of ML models quickly and put them out there in production. Right? This is a fundamental mismatch, and it does not bode well for either party if they do that, right? So that I think is another way of answering that question of shouldn't the data scientist pick up like ops, and shouldn't they pick up much better software engineering skills? Yeah, they should, but are they going to be happy doing it?
Yeah, yeah, that's not what their strong suit is. So, Lak, do you have a hard stop right now, or can I ask you one more question?
Okay, well, let's do one more question. I'll just tell the party.
I'm keeping you on here. I got you. I don't want to let you go. So another colleague of yours, Yvonne, was asking us, what is the plan around MLOps for Google and the Google MLOps vision?
That is a much larger question than we can do here. But no, we have a cloud AI platform, and we're continually enhancing it to support the needs of customers of various sizes and various levels of sophistication. So that in some ways, that cloud AI adoption journey, you can think of that as the way that we're thinking about where the market is. And you basically have on one side what a company wants to achieve with machine learning. Do they want to do strategic things? Do they want to do transformational things? Do they want to do tactical things? And then on the other side is the amount of workforce and who it is that works on ML at these companies. So now you have a 3x3 matrix, and we want to basically have the tooling that is that works well together, that's well integrated, that works for all of these users.
Lak, thank you so much for joining us. I'm going to throw the Slack invite link in the chat one more time. If anyone wants to jump in, we are having all kinds of MLOps conversations there. And we're going to be giving out 3 of these books that Lak co-authored, amazing books. I just really appreciate you diving into all of this with us, Lak. Thank you so much.
You're welcome, Demetrios. Thank you.
See y'all.